What I would like to do is to open up a notebook that we already have. Let's use the regression metrics cross-file score notebook and use it to take a look at how we can use hyperparameters to try to improve the scores that Decision Trees, Random Forest, and XGBoost are giving us. So go to your Google Drive. That's drive.google.com. You can click on your Colab notebooks, which should be underneath your folders. And then you should see down there regression metrics cross-file score. If you open it, double click, you'll know that it's correct. If you see the bike rentals data set at the top and you scroll down, you're going to see cross-file score and some different regressors. Okay, so what we're going to do is go ahead and I don't know if that we want to run all necessarily, because let's make a couple changes first. Okay, instead of like looking at all the scores, let's only look at the mean. And we can do that by, so go into the cross-val function, and then we're gonna change it to return rmse.mean. Okay. And then let's go down to this decision tree regressor. Okay, second one we did, and then go up to runtime and hit run before. So it's going to run all the code before. And sometimes I'm unclear. It's like, do they also run that still? It looks like they don't. So if we scroll up, you can see that with linear regression, it did give a score of 972, just the mean. And do recall, go ahead and run the decision tree too. Do recall that these are designed to be the lower the better, because we are using the root mean squared error, right? And what this means is, we pulled up this y-describe, standard deviation is almost 2,000, so you expect to be off from the mean by 2,000 on average. And so here we're getting a score of 1,200, which, we want to do better than that. So inside of the decision tree regressor, in any decision tree, any random forest XGBoost, there's a hyperparameter called max depth. So if you start typing max, you can see it actually shows up as an option, max depth. This is how deep the trees are. Well, it's probably overfitting, so you want to go low. There's no limit by default here. So what's low? I don't know. XGBoost uses 6 by default to try to prevent overfitting. Let's try 6. Let's see what we get. About the same. Maybe a little lower. Try 4. Worse. So maybe 6 is too low. I could try 8. Yeah, it's only doing so well. But the point here is that you can try different values. Okay. Yeah. Not sure what would be best here. So we're not seeing many gains with max depth there. Let's also consider max depth for the random forest regressor. Now this could be a little more interesting, because the random forest is taking many decision trees. So again, if we try something like 4, we can see what we get. 1,009. We could try something like 6. And by the way, the shorter trees also mean that they're actually going to build faster. Got a little better. Okay, so again, max depth is how many splits. Lower is better. I'm going to take this out. By the way, 731 rows is small, so there's only so much to learn. Okay, and some of these are designed like to learn a lot from big data. Now let's consider XGBoost. Okay, we got 797, which is really good to start with. And let's just try, their max depth is 6 by default. What if we lower it to like 4? Let's see what happens. 830, so not quite as strong. You can go as low as 2. 792, so that's good. You could consider, like, what if I try 2 here? I get better or worse? Definitely worse. Especially, I like to go back up and make it, try to get a more respectable score. Now note too, like what I'm doing here is I'm rerunning the code. When you're looking at a final notebook, you may want to show or say like what all you've tried. You could even do it using a for loop as well. Okay, so max depth is only one hyperparameter to change. Another one is the number of trees. And that's going to work for Oh, that's the random forest regressor. Sometimes we could just take ones out as well. Like, you don't have to use them all. I'm just gonna and even K-neighbors, I think we already tried going through all the neighbors. K-neighbors is not a tree base, so you can't use max depth 4. When I say take it out, I guess again, if this is the final notebook, you don't want to take it out. You want to actually leave it in, but you can just like add some coding cells if you want to clear out some space. Oops. Code here. I like to do that sometimes, so I'm not looking at it. I'm only having in front of me what I want to see. So let's look at in estimators. Okay. That's the number of trees. By default, it's 100. And you could think, well, what if I add more? Is it going to be better? Let's try. It is better. It's not surprising, but it's not always the case. The more trees, the better. It's same with random forest, so we can try that too. In estimators, up it to 200. See what you get. It takes a little time there. 968, so not really an improvement, okay? And note the difference in the two models. In the random forest, you're simply having more trees that you're taking the average of, but in XGBoost, you're learning from the previous tree. So it does make sense that more could be better. What if we up it to 400? Okay, 748 is pretty good. 732, it's a little better, right? So again, more trees, more learning is taking place here. In case you're wondering, it's not the case that simply, if you try 10 million trees, it would take too long anyways, but that like the more the better, eventually it does peak out. We don't know when, right? We can keep trying different estimates. 730, so it's still slightly better. And the other thing is you can do things in conjunction, see, because like max depth, well, I think basically more trees, max depth going down is going to help. You could try it like with a little variation. Try a 3 in there. And see, it's not as good, right? Because more trees, there's more to learn when there's only a little bit. And another thing on that note is that gradient boosting is designed for turning weak learners into strong learners, meaning if you have a tree with a depth of 2, there's only so much to learn, but all these adjustments, you can learn a lot. I'm going to go again to 800. Let's see, can we crack 730? No, it actually went up. Okay, so you don't want to have more trees than is giving you, like better values. Interesting, 500 got slightly under. And you see, does that mean 500 is better? Not necessarily. Like, look, it's 1729, 1730. They're giving you about the same. But in estimators is a really nice one that you can use to adjust. Let me put this on its own line too. What else? What else is there, and how do we find out? Well, it's nice when they actually do this. Who does what? When Colab Notebooks shows you inside of the parentheses, these are all the hyperparameters. They're called hyperparameters because technically the parameters are the values that the machine learning model actually uses to, I don't know, like select the model itself, but these are set in advance. And some of them are going to be, they're going to be different. You don't necessarily use all of them, but do you see that subsample? That's a randomizer that random forests also have. Like instead of looking at every, I forget if it's called a row, you only look at a sample of it. Okay, let's try that one. And the other thing, and there is provided documentation with this that you can click on, but what you really need to know is the range. It's not the values, it's the range. So subsample, call sample by tree, and call sample by level, and call sample by node are all percentages designed to prevent overfitting, and they all go between 0 and 1. Okay? And so when you know that, then you can use that to make the adjustments. So what do I do here? I can try subsample, and I could try like 0.8. Okay? I'm going to tell you 729 is pretty good. It's going to be hard to beat. So it may help, it may not, Didn't help. You could try a little higher. Kind of makes no difference. And if you're curious, you can even go lower, right? Yeah, kind of no difference. And so if there's no gain, again, when you're doing final projects, you want to show what you've done. Okay, you have a whole thing. What are we doing here? if we're in a project, let me show you. Add a new text. This will be for your project. Just do it now in this notebook. But you could say hyperparameter fine tuning. And you're basically showing then the different things that you've done, right? Because it's going to look good. I'm not taking the time to copy and paste the code in this presentation, but I think for you, it's good. Like for instance, hey, leave it, right? Don't necessarily erase it. Try another one. You know, what else do we have that we could try? And by the way, to show that you've tried, you can also put it at its default, okay? Because that will remind you that you can change it later. So learning rate is actually one to consider, okay? I honestly think of it as the rate that it learns. I can tell you that as in estimators goes up, the learning rate should go down. So if it was 0.1 by default, I mean, I don't know if 0.05 will make a difference. That's halfway between 0.1 and 0. And it could be that going up is better. But learning rate, you usually want small decimals, okay? You know, not better, right? Yeah, but these can also be tweaked, right? What about 0.8? You know, you're looking for trying to gain like slight improvements. Oh, it's also good to have up like what the best score was. Here's the default. Okay. 729. And then we can look at, is there a way to get it a little better, right? If we go a little higher, you know? And again, XGBoost is really good at actually picking a strong learning rate, okay? But if you do, let me try something like this. If you do like 1,000, okay, so it's going up, and then maybe the learning rate should go down to 0.0, it's 0.1, 0.075 maybe. Let's try that. So I'm just experimenting and trying out different number combinations to see. Yeah, it's going to be tough to beat the 729. And again, we've tried. We can move on. You would do no coding. So I'll just set it back to 0.1. Maybe try one more here. What could we try? We could try. Yeah, sometimes the call. Let's try the call sample by tree. Let's just try it. Okay. And by the way, in case you're wondering, call sample. It's not given to me. It's not been by tree. Maybe it's like that. By look, they're showing me now. I look. Do you see how the by and tree are together? So let me just try that. In case you're wondering, is this really the best way to do it? No. Right? This is a fine way to do it. And I want to show you all this way, which is simply trying out different numbers to see if you can find some gains. We don't need to do a ton of this, just a little bit, you know. As you can see, we got big gains just from max depth and in estimators. Those are usually enough to get solid gains. Okay, and they're going to work for any random forest, any XGBoost, for any data set. Okay, and we'll also have a chance at some point to take a look at GridSearch CV, which is a provided method of sklearn designed for hyperparameter fine tuning. My take with you all, since this is an introductory machine learning class, is that you understand primarily this way that, hey, there are hyperparameters that I can make adjustments to. I can try a couple to see if I can get better scores. And then for those of you who feel so inclined, you can try the GridSearch CV to say, you know what, I really want to get the best score possible. I'm willing to like dive into a little more Python to figure it out. Okay. But this should give you some leeway to have a little fun with it. You know, in case you're wondering, I mean, can random forest do better? Just really quickly, if we try like, see the max depth can be set to none. they have a lot of different things here. I said subsample. Looks like it's not technically subsample here. It's, I don't know. You just got to try stuff and you've got to look at the range. And I can tell you that when I look at these, sometimes try them in order. Min sample split. We could try last one for this lecture. Min sample split. It's saying 2. So what that means is it'll go all the way down. If there's, it's got to have at least 2 for a split, which is kind of like, if you think back to the decision tree image, you could say, well, wait a minute. If you've got like, we can basically raise that up, okay, and say, you know what? If it's 4, it's the number of samples, right? Right. If there are 2 samples, only 2 left, and then you can still split them into 1 each to get perfect predictions. So you can increase that to prevent overfitting. If min, I don't know that this will make a difference. We did a little bit because max depth is already 5. It could be that this is more like a number that's, we could try a much higher number like 16 and even increase max depth, okay? So understanding what they mean, yes, is very helpful, but simply playing around with numbers is also totally valid, You just got to know the ranges. We can get the ranges for you. My personal recommendation would be to use XGBoost. It's better on average, and it tunes well, and all the hyperparameter information at XGBoost will be provided to you.